Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. In my last video, I had talked about surface area and volumes, primarily about the surface area, that how can we find the surface area of different shapes. Okay. Today I'm going to take one problem and I will try solving that problem so that you have the understanding how to solve the problems related with the surface area. So the problem is a solid cylinder is of height 5 centimeter and diameter 2 centimeter. A conical portion of the same height and same diameter is taken out of it. Find the total surface area of the remaining solid. So that's the problem. So there is a cylindrical shaped solid object of height h and radius r, and the value of height and radius is given. The height is equal to 5 centimeter. The diameter is given. The diameter is equal to 2 centimeter, and therefore radius will be equal to 1 centimeter. So this is the solid cylinder. Okay. Now after that, a conical portion. This is the conical portion which has been taken out from this solid cylinder. So this conical portion, again the solid, conical solid has been taken out of the cylinder. The question is that find the total surface area of the remaining solid. What will be the remaining solid? This conical portion has been taken out. So whatever is the remaining solid, for that we have to find out the total surface area. So what will be the remaining solid? Remaining solid will be this. Because this conical part has been taken out. So let's look at that. What will be the total surface area? Total surface area of this solid will be curved surface area of the cylinder, which is the curved portion of the cylinder, and that we know that it is 2 pi r into h. Then there will be the lower circle of the cylinder still available, so that will be pi r square. What else? When this cone has been taken out, the internal area of cone shape is still available, because that is an area. Suppose you have to paint this remaining solid, then you will paint this outer curved surface of the cylindrical shape, you will paint the lower base circle, and you will also paint the inner part of the conical shape from which this conical solid has been taken out. So this area will also be forming part of the total surface area. Now this surface area is the surface area of the cone, and we know that curved surface area of the cone is equal to pi r into L. Okay, where L is the slant height of the cone. If I have to find out what will be the value of L, then I can figure it out from this relationship, because this is a right angle triangle. So the slant height will be equal to r square plus h square, which will be equal to 1 square plus 5 square, which is equal to root 26. Okay. Now, if I have to find the total surface area of this remaining solid, then it will be 2 into pi into r, which is equal to 1, h is equal to 5, plus pi into r is 1, the whole square, plus pi into r is again 1, and L in this case is root 26. If you calculate all these three parts, you will be getting the total surface area as 50.52 centimeter square. So this is how you calculate the total surface area of this remaining solid. Okay. Now suppose, rather than putting the question this way, if the question is asked that this conical shape solid is taken out from the cylinder, and what will be the surface area of this conical shape solid, then what would be your answer? Your answer would be, in that case, the total surface area of conical portion that will be the pi RL. You have taken out the cone, so I'm just drawing this figure. You have taken out the cone like this. So this curved surface area is anyway part of that, plus this outer circle is also part of that, so it will be pi r square. So that becomes the total surface area of the conical portion. You know the value of r, you know the value of L, you can find out. But suppose some teachers are very creative and they say that out of this solid, a very thin cone, like the way you get the ice cream cone, so that thin cone, very thin cone is created out of this. So very, very thin kind of cone which is created out of that. Okay. So all other portions have been removed and very thin cone has been created out of that. Then what will be the total surface area of this very thin cone? Now it is obvious that this, since it is very thin cone carved out, there is practically no difference between the internal radius and external radius. It's a very thin cone, right? So now in this case, the total surface area will comprise of this curved surface area of the cone, and you can reach out internally also because this part has been taken out. This portion, this solid portion has been taken out. So now you can reach out, and if you suppose you have to paint this figure, you can paint inside also. So this becomes the total surface area. So in this kind of situation, the total surface area of that solid will become equal to pi RL, which is available outside, and pi RL, which is available even inside. So that becomes 2 pi RL. But in this case, this circular area will not be available because it has been taken out. So only this very thin layer is available. So this surface area, outer one plus internal one, both are available. Therefore, the total surface area of that kind of shape becomes pi RL plus pi RL, which is 2 pi RL. Okay. So this is how different kind of problems can be framed in finding out the surface areas. It is very important to visualize that how the shape is appearing, and then which all surface areas will be available to us to either paint or touch it, and that's how we have to calculate the total surface area. I hope with this example you have clearly understood how the surface area calculation of these kind of shapes happen. Thank you.